Yeah, thanks for having us. I'm super excited to be here. My name is Bryan Costanich, and I am co-founder and CEO of Wilderness Labs. And I also have Jorge Ramirez with me tonight, who is a dev advocate at Wilderness Labs. And we're going to tag team on this. And I am actually, I will say this, we all miss in-person meetups, and I miss being out and in front of everyone on a stage and talking and seeing everyone. But it is nice that that we can do this in a virtual setting, in the sense that, like, I'm in Portland and Jorge's up in Canada, and we can make this happen. So it's not all bad. Certain some aspects of it are pretty good. So I'm like I said, I'm really excited to be here tonight. I think this is going to be kind of it's going to be a fun talk. And it's really, what's interesting about this talk for me is that if I roll back the clock 7-8 years, it was the very beginning of the Xamarin days. And we didn't have a developer advocacy organization or anything. So I would go out and I would give a lot of these talks. And I would go out and I would tell people how important mobile was, that mobile, was the very beginning of the mobile revolution. It was just kicking off. And I would tell people, look, if you're not paying attention to mobile, you're not paying attention. You should really be upskilling and learning mobile, because the next 10 years of your life, if you're a developer, that's probably a good chance that that's where you're going to be spending, your time. And especially if you want to be at the top of your earnings bracket and, you want to be in demand and whatnot. And so I used to go out and give this talk saying, the importance of mobile. And here I am 7 or 8 years later, and I'm talking about the importance of the next part of our computing revolution, which is embedded in IoT. So it's pretty fun to be doing this. But it's also a little bit of deja vu. So tonight we're going to talk about building IoT, and we're gonna be talking about how to do it with your .NET skill set using Meadow. And specifically, we're going to look at a little project that we built, which is called Klima. And this is like a prototype fun project for climate monitoring. So the idea here is that this can be a battery-powered device that can be put out someplace. It records temperature and other atmospheric conditions. And then serializes that data, sends it up to the cloud. In this case, we're going to show it connecting to an ASP.NET Core Web API site using the tools and APIs that you're used to. So we're going to use HTTP client, and we're going to send it up, and we're serialized via system.text.json. And then we're going to actually show some fun stuff with graphics and whatnot. And as I mentioned, all of this is going to be using the skills that you already know. Now, you can find a source for this if you want to follow along or you want to poke around up on our GitHub. It's just Wilderness Labs and then Klima. So definitely, feel free to take a look at that. But before we get into the project, I actually want to talk about IoT, about embedded, because IoT is incredibly important. It is the next part of humankind's technological revolution. It's the next part of our computing story. We've gone, in the computing story started with computers that were as large as a room, and then we shrunk them down in a desktop form factor, and then they started proliferating out in homes, and then the web became a thing, and it united, or some might say divided us, and then we took it even farther and shrunk it down. And I remember it was like 10 years ago, and Steve Jobs stood up on stage, and he had that just beautiful piece of glass, and he showed us the iPhone, and that kicked off the mobile revolution. And now we're transitioning into another epic, another part of this story. And it's really interesting because IoT today is actually already much larger than mobile. In fact, it's already 3 times as big. And in just a few years, there will be 10 times as many non-mobile connected devices on the planet as human beings. So this is not only an important market because of its size and the money spent on it, but just the sheer amount of connectivity and devices and things that are going to be deployed in the world is pretty massive. And that is going to spur a pretty radical shift in our lives and our interaction with technology. You know, we went from this idea of putting a computer or compute in every home on every desk to the idea that we can now put a computer in everything everywhere. And that will spur a shift in our relationship to the world, and it'll change, and that will change the culture of humanity around it. Like, I can't, you know, it's almost hard to remember what it was like to drive before Google Maps. You know, that's a revolutionary shift in like how we operate in society and whatnot. And it's interesting because just like the way that mobile changed our world, IoT will as well, because the interactive world is coming. This is we're moving into a time in which not only will we be able to get a lot of data and information about the world around us, but we'll actually be able to control it. We'll actually have power to change those things because we will have smart compute devices out there that can actually affect physical things. You know, that's the promise of hardware. And what's so interesting about this is that, unlike the mobile revolution, which gave us this really incredibly powerful hero experience in which, you know, you picked up the mobile. I remember picking up the iPhone for the first time and scrolling through and just being like, wow, this is the future. You know, that was a really perfect hero experience in which all of a sudden we knew our life was changing. But IoT is different because while this revolution is happening, it's more of an incremental thing. It's happening all around us in a way that doesn't affect us in such a singular experience. And so it's sort of emerging around us, and it's almost easy to miss. Now, I mentioned that IoT in the embedded space is already 3 times as big as mobile. Well, a lot of that is not in consumer IoT. That, you know, a lot of times we think about IoT and we think about, like, you know, smart fridges and smart ovens and things like that. And that's consumer IoT. And that's just a very small fraction of the overall IoT market. In fact, IoT is the market is split into 3 segments. There's consumer IoT, which is this little tiny segment. And then there's commercial IoT, which is like smart buildings, medical devices, asset tracking, things like that. And then there's this big market, which is industrial IoT. And that is by far the largest portion of this. It's like 75% or more. And that is really undergoing a massive transformation today because of edge compute. And so, you know, this is happening, but it's not really, like I said, the revolution is here. You may barely notice. So I think that there is no better time than right now to upskill and to start learning how to do embedded IoT. And when I say embedded IoT, you know, we're going to talk about that a lot tonight. What does embedded mean, and what does it mean in the context of IoT? But about 95% of all use cases in IoT are actually embedded use cases, and we'll talk about what that means. But it is really a time to learn how to do these things. And we're going to show you tonight how you can use your existing skill set to actually open this field up to you. And first, I want to talk a little bit about what embedded hardware means, because this is a revolution that has been brought to us by microcontrollers. And okay, so what the heck is a microcontroller? Well, microcontroller in its simplest form is basically a computer on a single chip, but it's also built to control hardware. Now, microcontrollers were brought into the world by Intel back in 1971, and this 4004 chip is a very famous chip. It was the first time in which all of the things necessary to actually have a computer was on a single IC, a single integrated circuit. But it wasn't just about compute, it was also about controlling hardware. So that chip could listen to analog inputs and measure voltages. It could control IO. It could like turn things on and off. So it was both compute and hardware control. And the thing about microcontrollers, just to be clear, they're not CPUs, they're not app processors, they're not what you would find in a single board computer like a Raspberry Pi, they're not what you would find in your computer. They are tiny little things, and there are trillions of them in existence. In fact, today, if we look at this by sheer number, microcontrollers are the dominant form of computing on the planet. And though they might not be the dominant form of compute in terms of processor time or computing power, they will soon be. And they are all around you. 30 billion of them were shipped last year, and a modern car might have 100 of them in there or more. This is a microcontroller in it. You know, every little toy or appliance, it's all controlled by microcontrollers. And the litmus test of what is a microcontroller, is it a microcontroller or not, is does it run an OS? And this is the sort of line of demarcation. Microcontrollers don't run full OSs. You can't put Linux on them. They run micro real-time operating systems, and those binaries are measured in kilobytes rather than megabytes. They're very, very tiny. And unlike Linux or other operating systems, there's no concept of multiple users and multiple apps. It's just a single application experience, and there's just enough operating system to service that app in the hardware underneath it. So it's a different concept. It turns the idea of an operating system on its head and makes the app the focus. That's the thing that runs on microcontrollers. And they're also ultra low energy. So compared to like a Raspberry Pi, for instance, the chip on our Meadow device runs at 1,000th of the power usage. So this is something that you can run on batteries, you can run from solar panels, and definitely you can deploy them in the field. They don't have to be plugged in. You can do energy harvesting, you can do power over Ethernet. So this really opens up a lot of places where we can put compute that we couldn't put compute before. And what's interesting about all this is that even though they've been around since 1971, this revolution wouldn't be possible without the mobile revolution, because the mobile revolution made modern embedded computing possible. That brought us just a wide array of wonderful hardware that is small, commodity, cheap, low energy, reliable, and gave us just such a wide array of sensors and displays and all these things. And so even though embedded is the new thing, it really wouldn't be here without mobile. So today we're going to talk about Meadow, and Meadow is a platform. It's a full stack IoT platform that enables you to run full .NET applications on a microcontroller. And the microcontroller that we're going to use today, the dev board that we're going to use, is a Meadow F7, and you can see it there in the picture. And it's hard to tell from there the scale, but it's very small. So if you see my screen, if my video here, this is a very, very tiny board. And that is in the Adafruit Feather form factor. So that's an industry standard form factor. So you can plug in Adafruit Feather wings and whatnot. But you can think of this as having the compute power of basically a classic Pentium. So it's pretty powerful, but it also has a whole bunch of hardware I/O. So this thing is built to control and integrate with hardware. So it's got input, output, it's got IOs that you can control and turn on and off. It's got analog input, so you can read sensors. It's got all of the peripheral protocols that you can think of, I2C, SPI, CAN, etc. So you can connect with just about any any peripheral out there, any type of piece of hardware you can connect this thing to and run it. It also has, and this is really fantastic and speaks to what has happened in the last 10 years in hardware. It also has 2D graphics acceleration, and we're working on exposing that in our APIs, so we can make, you can do touch screens and have really responsive experiences, graphic experiences driven by this thing. Has JPEG encoding, so you can run video through it. Hardware accelerated in crypto and all sorts of other cool things. It's also incredibly secure. So this chip, in fact, we're going to be turning this on pretty soon. You'll be able to encrypt your firmware, so when you send an application to it, it can check on the chip and make sure that your signed application, which is also encrypted, matches the keys that are burnt into one-time and read-only programmable memory. And so you can't sideload applications. It's very, very secure. It's really revolutionary. And the great thing about this is that you can actually develop on this and go to production with the same hardware and same code. So traditionally, embedded and IoT solutions have actually been built twice. Usually you prototype on an uploadable platform like Raspberry Pi, and then when you're ready to go from prototype to production, then you have to rebuild and rewrite for embedded. Well, no longer. Now, out the gate, you can start and build on embedded and then go to production with all the same goodies. And that really reduces your time to market and makes things a lot easier. And as I mentioned, you can run full .NET applications, and that's the magic here. Now, I want to actually, before I go on and talk about other stuff, I want to actually, Jorge and I are going to walk through creating an application and showing you what that looks like. And we're going to walk through things. But I just want to give kind of like a 30,000-foot perspective of, okay, I want to go and build an IoT solution. Where do I start? Well, the first thing is you want to pick up a board at our store. And I recommend getting a HackKit Pro. What we built today, Klima, can be built with a HackKit Pro. And a lot of our projects are all based on this HackKit Pro. So it's a good deal. You can get a bunch of sensors and motors and servos and displays and an F7 board and everything. So that will get you moving. And then the next thing that you would do, you come to developer.wildernesslabs.co. That's our documentation site. And so I want to build, I'm a client scientist, and I want to build climate monitoring stations that are going to be deployed in crazy areas all around the globe. It's going to be solar powered, and it's going to upload, sensor data to the cloud. So the first thing that I want to do is that I would go here and I would check out our peripheral driver library. So we have this thing in our stack called Meadow.Foundation, and Meadow.Foundation is a open source library of peripheral drivers and libraries to do IoT. And the awesome thing about this is that with Meadow.Foundation, this makes IoT plug and play. You can go to Adafruit or SparkFun or wherever, and you can buy peripherals, you can buy sensors and motors and displays and whatever. You get them home and you plug them in, and they just work because we have drivers for those. So let's take taking a look at this Meadow.Foundation. The first thing that we see here, so this is a page that shows all of the drivers that we have today, and we have over 100 drivers that you can for stuff that you can build in and just go. And it's split into two things. There's Meadow.Foundation Core, and those are like generalized things like RGB LED, analog joystick, push button, things that aren't like specific peripherals, and that comes in the Meadow.Foundation Core package. And then all of the other drivers that are specific, like specific pieces of hardware, like particular displays or particular feather wings or ICs or sensors, etc., are all in their own NuGet packages. So you can install them all via NuGet. And the great thing about that is then you can only, your application just has what you need to support, your app. You don't need to install a bunch of big, heavy packages. So looking at this page, the first thing I would do is, okay, I want to listen to temperature, humidity, and pressure. So I come and I see, oh, look, there's this BME driver. That's pretty cool. Looks like it's up and running. Here's our source code for it. It links right into the driver. This is where you can find it. So links to purchase it. Beautiful API docs on how to use it, and then also circuit diagrams so that you can literally just follow the pictures and plug it in, and it just works. Now, I want to talk a little bit about Meadow.Foundation because we did some really, I think, interesting things. The first thing is that whenever I start building whenever I start building a new IoT project, the first thing that I do is I get the pieces and I just get the pieces working. And so the easiest way to do that I have found is to clone the Meadow.Foundation solution and then open it up in Visual Studio. And you can use Visual Studio for Windows or you can use Visual Studio for Mac. I'm showing it here on Mac, but Jorge will show it on Windows. So I clone the package. I clone the project. And in here, you'll see well organized is all of the drivers. It's a pile of drivers. And like I said, there's over 100 of these. And in here, in some of these, there's actually more than one. So it's a lot of drivers. And so I go and I want to go look at the BME 280. You can open it up and you can see it's all, I mean, it's all well documented. You can see how the sausage is made. If you want to extend this driver or you want to change it to suit like some particular use case that you have, you can. But the important part here is that every driver has a sample. So here's the BME 280 sample, and here it is. You can just, if I had a board with the BME 280 plugged in, I just hit, set it as my startup project and hit play and deploy, and then it runs. And this is really nice because it just means that it's super easy and fast to get rolling. Now, I want to talk about something that we did in Meadow.Foundation that I think is really cool. So with sensors, we have two models. You can subscribe to just classical events. So in this case, here is BME 280.updated, and you can see, it sends a result which has an atmospheric conditions packaged in there, and then you can, output the information. And then when you're ready, you just you say start updating, and you can pass some overrides in there, like how many samples do you want to take? Do you want to oversample? That means like take multiple readings and then average them. How long do you want to wait between these things? And it's all kind of automatic for you. And that's really nice. The other thing that you can do is that when you said start updating, by the way, you can also just read and forget it. So you can just read conditions and just, read it and move on. So if you have an occasional reading you want to make, super easy. But the other thing that we've done here is that we have this ultra modern iObservable pattern. So you can use like a reactive style programming. And the awesome thing about this is that you can pass in a filter. So you can pass in a filter, which is just a predicate that says, look, only notify me when the temperature has changed by a degree and the pressure is changed by, like 5. So you can do these really nice filtering and then not have to worry about all the noise, and we handle it all underneath. So, definitely check that out. Check out the source code and whatnot. That's definitely the easiest way to get started there on running, on getting sensors going and whatnot. I'm going to hand this over to Jorge, who is going to actually walk through doing, he's going to walk through creating a new application, show you the experience of like actually creating a new Meadow app. And then also he's going to walk through Klima. So Jorge, it is all you.
All right. Thank you, Bryan. Can everybody hear me okay? Okay, perfect. All right. Yeah. So my name's Jorge. I'm a developer advocate for Wilderness Labs. I'm almost the main creator of making all these cool projects that you can build with the Hackit to get you familiar with the platform. But tonight I'm going to show you our project here called Klima. And what Klima does is an end-to-end hardware solution that you can send data that is being censored by this little thing. It looks like a little transistor. It's actually a temperature sensor. It'll read the temperature of the room and it'll send it to an ASP.NET Core web API that I have running on my computer. So let's start digging into it. So I'm running 2 instances of Visual Studio. This one that you're seeing right now is the klima.server host project. And this is just the server, the ASP.NET server running. Pretty simple stuff, everything C#, everything .NET that you're very familiar of. So the thing that I want to just bring your attention is our structure, our data structure here is just a dictionary that has a climate reading method, a climate reading property here. And we're just hard coding it with one value here in the dictionary. And we're just exposing two APIs. Very simple, one API to post climate readings. So we can get post client requests to give me a reading, and I'll put it into this, I'll add it into the server's storage dictionary. And the other is get request, that is get climate reading, which will basically get those get requests and just return them all the list of values that they have at that time. Pretty simple. After you run this application, you'll open a command line like this, and to tell you the IP address that you'll need to take note. And you can already just start testing. Sorry, you already start testing the server API, make sure it's working. So I have a little browser here running. So when I do that, it'll bring me a JSON response with the information that I told you is the sample data that we have to kick off things. So now let's go to the very interesting part. Let's go to the Meadow side. So pretty cool. This is the Klima solution project. Notice we have several projects here, including the server projects. We have two flavors of the Klima project. One ends with the Hackit on the name. This is the one that you can build with the Hackit out of the box. And we're trying to make a little, like one that has a little bit more meat, more sensors. It'll make it more complex. We can scale it even more, which will be the Pro version. And this one's running the I think we're using the BME 280 sensor to not only monitor temperature on the room, but also we can get pressure and humidity as well. But let's stick with the Hackit for now, with the Hackit version.
We're also, what's cool here is that we're sharing our code between the Meadow app and the ASP.NET app, because they are just a .NET standard. You know, both of them are just a .NET standard library. I think this one actually using a shared project, but you can use .NET standard as well.
That's right. Yeah. So we also have, like, I think both actually use the contracts, which has the same business model, the model of the project that is going to be used across the Meadow side, which is the client, and the server side, which is the ASP.NET side. But let's go back into the Meadow project. So the first entry point of the app is the program, the program.cs, and it'll instantiate the Meadow app. So Meadow app is, take it as the main project where everything is just unravels. Everything, like the whole logic of the app starts here. I'm going to walk you through, I don't want to dabble too much into the logic, but I'll do my best to try to get to understanding everything of what we have here. So when we first new up a Meadow app class, we call it first method, which is initialize. And our initialize method is focused only on just setting up all the peripherals connected into the Meadow application, to the Meadow board. So, and as Bryan mentioned, the Meadow.Foundation is super powerful. So notice that the first thing that I do here is we're instantiating RGB LED object. And we do it by passing the pins, the onboard pins, to those LEDs that are inside the board. So once you instantiate that, you're telling me, hey, I want an LED. These are the pins that are connected, and already the object has this awesome built-in high-level APIs that you don't. There's no like, we remove the guesswork from you, so you can just use set color, and we already have a struct or a enumerable here, and it's like perfect. So what colors do you want to set? So we have all these ones. We have one that is more fancy because we can use pulse width modulation, so we can do like we can get like all different kinds of hues of the LED by varying the voltage on each pin, which makes it even cooler. But for now, I'm just focusing on just setting up to red to just indicate, give users some feedback that, hey, the initializing process has started. And the next thing we're going to do here is, well, we got our analog temperature sensor, which is our little transistor here that I showed you before, this little guy right here. And notice that it's connected with the analog port, which is right here, the analog 0. That's it. So initializing pretty easy. You pass in the device object within this, which in this case is the Meadow F7 micro, and we pass in the pins which are connected. And with our driver, we need to specify the known sensor type, because there could be many other types of sensors. In this case is the LM35. And that's it. That's all you need to initialize the analog temperature sensor. After that is, you have an object, you can use it however you want. And so we also wanted to make, we also have drivers for the display, of course. And we wanted to abstract it or encapsulate it into, so we can make it like more powerful in our project, so we don't have display graphics, logics splatter all around the application. So we abstracted, we created display controller, which is, this is particular for this app, but you might want to do it whenever you're making complex solutions. You want to put controllers for each peripheral, so you can like empower them and put all different logic that you'll need to make your application. So notice that here we have the ST7789, which is the actual display that comes in the Hackett. And we also have a graphics library. The graphics library is something that we've built in-house in Wilderness Labs. It's a very lightweight, a very efficient way to write, to draw things into our displays. And the cool thing about our graphics library is display agnostic, meaning that whenever you have any other display running, laying around, you can connect it, and you can just by simply doing, I'm going ahead here, but if I go to initialize display, we initialize the display by setting all the pins that is connected, pretty much like how we did it with the analog temperature sensor. But with graphics, the cool thing is we pass in the object of your display, and now you can use the graphics object to do all those kinds of things. You can draw graphics, you can draw text, you can draw images as well. So all pretty cool stuff. This is also, you can see, as Bryan mentioned, all these specific hardware things that we have are already available in the NuGet gallery store. So we have, you can see we have the display TFT SPI. That's the NuGet package we're going to need for this display in particular. And maybe you can deep down a little bit. You can see that it has a reference to the display graphics library. So already ships with the graphics library already on board. So no need to look for that one to add it as well. It just has it out of the box. And we also have a simple JPEG decoder. I'll show it for you in a moment what we're going to do. So here in display controller, we have other methods here like update display, and update display receives an atmospheric conditions object, which is in this case is a value that the sensor has read at that time, and it calls a method called render. And let's take a look at what render does. So okay, so here is the render method. The first thing it'll do, it'll just clear out the screen completely. It'll go black for a second, and then it'll start drawing all these. You can see all these APIs that we're using in graphics to draw into the display. So we have draw triangles here. We have a draw circle. We can set the X and Y and the radius of the circle that we're drawing. Is it going to be filled, which is the true value here? And what color do you want to draw the circle as well? We have this method called display JPEG, and this method is what basically does is it'll load a resource, which is this little image here. It's a little Meadow logo, a JPEG image that I add into the project. It'll call the code JPEG. Sorry, it'll call load resource first. and it'll reference the resources in your resources on your project, and it'll return the byte array. And this is all very C#, very .NET things that you're used to. It's something that you've done maybe in .NET already in desktop apps, or even using on Xamarin as well. So it's all very familiar to you. So you have, once you get your array of bytes here, you use the JPEG decoder, which is the one that's going to interpret the way you're going to read the bytes. And that's it. You're going to iterate through the arrays, and you're going to draw pixels, and that's how you're going to get your image rendered onto your display. All pretty cool stuff. So let's go back to the display controller. And after we initialize the display, we haven't drawn anything yet, but then we go and we do a device in the init Wi-Fi adapter. You know, as you know. Oh, let's start my yeah. I think Bryan already told me to start my project here. Let's do a deploy while I keep explaining all this stuff. Okay, while the app is running, I want to keep telling you what else is here. So we have a init Wi-Fi adapter, and this will activate the ESP coprocessor. It's the one that is in charge of doing all the Wi-Fi connectivity. And we finally reached the end of the initializing. So to give feedback again that initialization has been completed, I go back into my RGB LED object and I set it to green. And now you can see on the board once it goes green, you're already good to go. Let's see the, okay, so, oh, I think it's starting to, I think it's about to start right now. Let's see if it's running. Okay, it's deploying right now. But in the meantime, I want to continue here showing you. Oh, wait a second. Here it is. Here's the LED turning red. It connected. Now it's green. And now it's gonna sense. It's gonna use the sensor to read the LED, and then we should have a reading here. Oh, it says connecting to Wi-Fi. Let's leave that there for a second, and I want to continue showing you what else I have here. So after going through the initialize method, we go into the part where we call the Wi-Fi adapter again, and we do connect. We connect, we pass in both your Wi-Fi name and the Wi-Fi name and the Wi-Fi password to connect into your local wireless network. And it'll return you a result, either if it's successful or not. And once you get successful, it'll call this method called readTemp. And readTemp, it'll just activate the analog temperature that we did before, and we do .read, and it'll return us the value, the temperature value on the room in this moment. And then once it does that, we have here we get the result and we set it into this local variable, atmospheric conditions. And now we do update display. And update display, we pass in the conditions that the sensor has read, and it'll start drawing the sorry?
The render loop.
Yeah, it'll start doing the render loop. It'll start going through all the logic. I'll show you about writing all the shapes and text of the display. Oh, and here it is running. So right now it's a little cozy here. It's 26.6 degrees Celsius. I don't know how much is that in Fahrenheit.
Warm. That's warm in your house.
So after that, yeah, we
that's how we know that winter's coming in, right? Because you've cranked up your thermostat at home.
I'm from South America, so I love
not having any of that cold.
Yeah. So yeah, thanks, Brad. So we go back into updating the display. You're already seeing how it looks. As I showed you, we're using the graphics library to draw all these the squares, the little circle here, and your image along with the draw text display as well, the draw text method to write the actual temperature that the sensor pick up at that moment. And now, after doing all that, now we use the climate service facade. Now let's go for this class for a second. So this is a static class, not much going on here. It only has two methods, and it's the one that this class is in charge of sending API requests, HTTP requests to the server that is running also on this computer. So we have this one is the post temp reading, which it's called to send the value read, and we send it to the server running. The server is going to pick it up and it's going to add it into the dictionary that I showed you previously. And the other method that we have here is the fetch readings. And fetch readings is just as you see, we're using normal HTTP client that everybody here is very familiar with. And we do a get async passing the climate data URI, which is right here that has already my IP address along with the port and the URI for the API entry point. And that's it. It'll return me the list, the response, and the cool thing, we're also initializing. I mean, we're serializing and deserializing using the system text .json, something that it's all in NuGet. So we can just go in NuGet gallery store. You can pick up whatever NuGets you want, and you just add into your Meadow project, and you just run it, just like you would use on an app. Like I'm a Xamarin developer, so I do this all the time. So it's very, very exciting to have the capability of doing all these familiar things and doing it on hardware. I think it's pretty cool. So after doing that, we do fetch readings, and we go back to our Meadow app project, our Meadow app class. It does fetch readings to get me all the list of the readings that the server has at that time. We call then the post temp reading, and we pass in that value that the sensor picked up at this moment. And here we are when we're sending conditions.temperature. It's the one that the sensor has already picked up. And then once it does that, we call again fetch readings to get the list of updated values from the server. And it'll end the execution with this this quote here that Bryan put about, I think it's from
Blade Runner. So it's important to note that this, this project here is a sample project. It's meant to be simple. In a production, application like this, what you would probably do is then you would put the device to sleep to save energy, and then schedule a wake up maybe in a half hour, or maybe you want to take a reading every 6 hours or something. And so we're working on APIs around power and sleep. So you can do that. You can cycle down, put it to sleep, and then the chip internally will put most of itself to sleep. And then there's like an internal small part of the chip that uses very little juice, and there's a real-time clock, so it can schedule a wake up, and then it will bring itself back up online. And then you get a notification in your app, just like you would in like an app delegate, like if you're building an iOS application. And then you can start the process and do everything that you need as well.
Yeah, correct.
And the takeaway here is that this is just a .NET app. This is, if you know how to build .NET and you can follow some Lego instructions on how to plug in sensors and whatnot, you can be an IoT developer.
Correct. Yeah. Something also really cool is the Meadow also comes with this mechanism called watchdogs. So if your application is running in a very remote area and your application for some reason stops executing, there's this little part of the chip that it'll start just constantly checking to see if your app is running. And if it doesn't, then it'll just reset by itself, and it'll execute the app again and pick up whatever it left off in its, in configuration files and whatnot. So also it's something that, is pretty important to always have backup mechanisms, especially for projects that you'll have running in, who knows, like in remote areas. So very important to keep that in mind.
Yeah, adds reliability for, critical app infrastructure and whatnot. So make sure that you don't lose your power or something if this is in the power generation station and it's doing some whatever, which, microcontrollers do.
Exactly. Yeah. So yeah, I think I've reached the end of this demo. I think I might have gone a little bit fast.
No, it's
This
awesome.
this project is completely open source, so feel free to download it and dig into more detail if you want to and get more familiar with everything. So yeah, I'm glad. Thank you, Bryan, for letting me join this meetup to try to walk you through a little project here that we built. It's pretty fun. Thank you.
Absolutely. Awesome job, Jorge. If you want to stop sharing your screen, I'll go back to the.
Yeah, of course.
Actually, real quick question, if I could just interject while we're in a transition too. And so I mean, you talked quite a bit about yeah, the Meadow.Foundation stuff and some of the abstractions and nice APIs that are in there. I did see, you know, as you were going through some of the code, there's also some very device-specific APIs in there. Like I wrote down like a ST7789 class for some of the, you know, specific hardware that you're doing. So I guess just out of interest, what does the normal split end up looking like? Like how often do you find yourself in this world coding for very specific little bits of hardware versus abstractions, or what does that end up looking like in practice?
So the nice thing there is that we've actually interfaced almost everything. So in this case, the ST7789 implements iGraphics display. And so all of the, Jorge, you want to let me share my screen? I'll go over to the, so like all of our display drivers, everything that implements iGraphic display will have the same set of APIs. So you can use, you know, you can swap them for whatever you want. And so, and in fact, if you look at the peripheral driver list and you go to displays, you'll notice there's a pile of them in here, and they all, you know, they all basically, the graphics displays all work the same. And then some of them are text displays in which they implement iText display. And so like, for example, the LCD display that comes with the hack kit, that's like it's actually a 4x20, but it shows text. Well, there's also 4-segment display here, which also shows text. And so those implement iText display. So the calls that you would be making to actually drive those are the exact same. So when we have done that across Meadow.Foundation, everything is interfaced. Everything has a contract. And in the future, what we'll do is it will take it even further. So once something implements iGraphics display and you want to draw something to that, we'll automatically down sample for like, you know, going from 32-bit color to 16-bit color to even grayscale or black and white. Like we're working on abstracting that even further. So that's really the idea behind Meadow.Foundation, is to really have a unified API and unified architecture around those things. Awesome. Well, let me show you, you know, so thanks, Jorge, for that demo. I think, yeah, fantastic job. One thing that I want to point out is that, you know, Meadow is still in beta. There are still some big pieces missing. We're, you know, we're in our final stage of beta, and we're marching towards production, towards it being production quality, but there are some major pieces still missing. So you can't run a web server yet. We're working on the last few calls to implement HTTP server. So this will be awesome. You'll actually, you know, you imagine going up to a device that has an e-ink reader, you scan it with your phone, it connects over Bluetooth, and then that pulls up a web page from that device. You know, something like that, that use case could be so powerful. Imagine like a logistics tracking device that's on the side of a shipping container, and it has sensors that's communicating with inside. And you know, you need to get a manifest of what's inside there, and you can walk up and scan it, and it serves up from the device. So that's something that's, you know, we actually hope to have that finished internally at the end of the month, and we'll get it out in beta shortly after. We're also working on SSL support. So no HTTPS today, but that will be here shortly. And Bluetooth is still in flight, as well as debugging. So you'll see, as Jorge was going through a lot of that code, there's a lot of console.write lines. So we found in practice the missing, like not being able to step through and debug isn't really such a big deal because console.write line gets us through. But we are working on that, and we get a lot of that for free because of Mono, which is nice because underneath it's all supported. We're just right now we're working on the plumbing on device and on the IDE. And then there's further stabilization. So there's some bugs here and there in the GC and whatnot, and we're working on those, ironing out those last remaining bugs. But we've come a long way, and it's a productive platform. And if you have IoT projects in mind and you want to go to production and you want to build commercial stuff, it's a good time to start prototyping, because it'll take you a little while to do your prototypes and get those up and ready. And as you're working through those, we're releasing new features and new releases all the time. So absolutely don't let the beta tag hold you back from playing with this, because it's, like I said, it's very productive and pretty fun. And also, you can find all of these goodies. If you want to get rolling, you can find them at our store. It's just at store.wildernesslabs.co. And once you get a hack kit, there are piles and piles of projects that you can go and check out. So you can find this later if you go to developer.wildernesslabs, view more projects at Hackster. And Jorge has built nearly all of these. And there's this fantastic projects here for all kinds of fun stuff that you can do. Here's a radar. Here's a radar screen that you can do that uses a servo and a sonar, and that is inspired from the GUI and Alien. So if you have a keen eye, you can notice the radar there. All kinds of cool projects, and everything in the hack kit. We've just about everything in the hack kit. We have examples of how to do cool stuff with and whatnot. So absolutely check that out. And there was a question in the, can you also integrate with Azure IoT Hub for enterprise grade? Not yet. Azure integration will be in the future for sure. Yeah. So thanks for having us. And it's awesome to be here and show this off. This has been a long time in coming. I know some of you folks may have been on the Kickstarter, and that was almost 2 years ago now. And we've been working on this for a long time. It's a really hard project, really hard problem that we tackled. And it's fun to be here, and it's fun to show you, we're at the stage where it's like a productive platform. And it's fun to show you end-to-end, real-time, real-world scenarios, and connecting to web servers and uploading and downloading and using NuGet packages and all the things that you expect from a .NET platform.
Was that really 2 years ago? That statement just made me feel old.
Man, time is going. 2020 is. Well, I don't even know what this timeline is. Yeah, it was 2 years ago. We've been cranking on it for a long time.
Yeah, it goes fast. I guess one other question that I'll seed here, because I don't see anything else kind of pending other than a whole bunch of excited folks that sound like they're going to go buy a kit and play with some stuff. Even thinking back to some of the early questions that we were fielding back in the day with Xamarin, with a similar type of promise, right? Like, what does it feel like in practice to pull down packages from NuGet and start using them on these constrained devices? Like you mentioned, for example, using system text JSON, which is the new hotness there that performs way better on all other platforms. Do you see similar gains on these little devices, or are there any gotchas to kind of be aware of?
Yeah, you are building for a microcontroller, and that's something, you have to keep in mind. There's 32 megabytes of RAM and there's 32 megabytes of flash, which is a lot for a microcontroller platform, but we did that so that, you have space to play. But you will run into things like, if you wanted to do, like, for example, if you wanted to bring in the reactive library, that brings in like 64 megabytes of stuff. And that may actually work at some point, because we'll be linking stuff out. So we shake the binary tree, and all the stuff that we're not using just falls away. So we can shrink that stuff down. But you do have to, ultimately it was like learning Xamarin iOS. You're on a new platform, you're on a new piece of hardware, and there are things that you have to consider. And you want to keep your code lightweight, and you want to keep it tight loops and whatnot. So there are certainly things that you want to consider. Now, with that said, out of that 32 megabytes, I think most of that, I think like 30 megabytes is available for use from a user perspective. And that's non-volatile storage. So you can use it as a hard drive as well. You can like use system.io file stuff. So you can actually drop files on there and whatnot. And so it's constrained, but it's also, we put some room on there for you. But there's, certainly things that you don't want to do. I mean, I can't think of anything offhand, but the reactive is a good example. I noticed someone says, so what is Meadow compiled down to on the chip? Is there an embedded CLR or something, or just assembly? So this is actually an interesting question. So Meadow OS, the stack that actually runs on the chip, at the bottom is a micro RTOS called NutX, and that's an open source micro RTOS that's been around for like 17, 18, 19 years. And the kernel is just like really beautiful. It's a beautiful piece of engineering. And on top of that, we've ported the Meadow runtime to this chip. So we're running Meadow in the context of NutX. And then on top of that is the Meadow Core APIs, which expose all of the hardware through to .NET. And today, code's interpreted. So it's performant, but it's not blazingly fast. Now, we do intend to turn on AOT. Now, AOT is a little bit tricky for us because so the back end for this is actually Thumb 2, which Mono AOT doesn't support today. So we have AOT working in Hello World. We can compile down to LLVM, and then we compile to Thumb 2. That's the architecture. But then it crashes on anything other than like Hello World. So we're working on that, but that's a piece of heavy engineering that we have left to do. And that should give us about another 10x performance boost, because the interpreter is good today, but it's not, it's not AOT. So we will be going down to Metal at some point, but it is certainly still interpreted. And that means that there are limitations to, some of the things that we can do as well. Like there's certain sensors out there that like require really tight timings, and we can't quite hit them yet today, but we're close, and we will for sure. How does Meadow compare? Another question. So how does Meadow compare with Raspberry Pi and other IoT solutions? What are your advantages? So that's a really great question. So Raspberry Pi isn't really IoT. Raspberry Pi, it's not an embedded solution. That's a single board computer. And that's great for like kiosk applications and whatnot, but hardly anything is ever deployed on Raspberry Pi. Typically, people rebuild and rewrite for embedded hardware, for microcontrollers, because Raspberry Pi ultimately becomes, it's much more expensive, both in power and then the hardware, et cetera. So they're not really comparable. That's a different class of compute. This is true embedded, this is really embedded stuff. So for example, we have this SMT chip. This is a the SMT means surface mount technology. And that's how circuit boards are done today. So that's things are just put on them instead of through hole. It used to be that, there are a bunch of drill holes and then you put things through. Well, now everything's just on top. So this is our embedded chip, and it's, This is basically the same as this, minus the USB connector and I forgot to mention this as a battery connector and a charger built in, which is kind of neat. But this runs full .NET, and this is very, very, very tiny. You can embed this just about anywhere, and you can run it off of a battery. That's not something that you can do with, compute platforms that are further up the chain, like Raspberry Pi, Azure Sphere, et cetera. All right.
Awesome. Well, I guess I'll start doing an outro, and if someone starts to chime in with a question, we can reverse course and go back. But I really appreciate everyone's engagement. I mean, the questions were awesome. Again, going back to what I was saying up front, that's what makes this fun, for it to be a bi-directional thing. And I just had to stall for a second. And are you closer to Arduino?
Yes.
I knew it.
Yes, we are basically an equivalent in compute. So Arduino is also a microcontroller platform. So that's exactly it. We're in the microcontroller family, just like Arduino is, except with .NET.
Awesome. Well, I'll start going through my spiel again, and we'll see what happens this time around.
But
really,
1 second. Sorry to interrupt. It might be important to note that we have some stuff that we're actually working on now, which is Meadow Cloud, that will enable you to manage these devices in the field at scale as well. So we have several commercial customers that are in actually getting ready to deploy Meadow by the tens of thousands out in the world. And in order to manage those out in the field, you need to be able to push over the area updates and do push messaging and communicate with those devices and stuff. So we're working on that right now, and that's Meadow Cloud. So that will enable you to manage them in the field at scale.
Awesome. Well, the last question that just came through, I feel is for me and not you guys, so that lends in nicely to be giving this a third shot. But yeah, again, thank you for everyone for attending. This was really awesome. The recording will be posted up on our YouTube channel. So the link is earlier up in the chat, or I'll post it on our Twitter account or our meetup page as soon as it's available, generally within the next couple of days, depending on how my schedule goes. But it's we try to get them up pretty quick because we know folks want to rewatch the content and kind of go through everything again. Let's see. Sorry, just saw the new question coming in. So I can say, and I guess this is maybe putting you guys on the spot, but we don't have anything else. We don't have anything else personally scheduled. We'd be happy to have you guys back at some point in the future. I don't know if you have anything else scheduled that's worth plugging here for folks to follow you outside of our illustrious group.
This is actually a great question. We are going to be at .NET Conf on Thursday, and I think we are going to be at 3:30 p.m. Pacific time. So tune in to .NET Conf and catch us there. And we're also on Twitter. You can find us at Wilderness Labs, and we have an awesome Instagram, which is powered by Jorge, the one and only, who does 99% of all the posts up there. It's actually really fun to follow because we also post stories occasionally as we're building stuff. Just fun stuff to see on there, and I think that's probably the best way to. I don't know. Jorge is our marketing whiz these days. So we got a blog.wildernesslabs.co. Honestly, like Twitter is a great place to follow us and Instagram, I think.
Perfect. Well, guys, thanks so much for coming on, hanging out, giving the awesome demos and really tag teaming this and going through all the questions and everything. This is a long time coming. I know we've been talking about doing this for a while, and I'm excited that we're finally able to do it. But thank you guys so much.
Yeah, thanks for having us. It was fun. It was a blast.
Absolutely. And thanks again, and as always for everyone who's been hanging out and asking questions and really making this worthwhile. Hope you all stay safe and healthy, and the video will be up in the next few days. So we'll put links everywhere, and hope to see you at future meetings.
Buy all the Meadows.
All right. Have a great night, folks.
Great. Thank you.